Hello everyone, my name is Satvik and I am here to discuss about an interesting problem on probability. Before going into the problem, let us know about the information required. Three people have left traces of their own blood at the scene of crime. Their blood groups were found out to be O, B and AB, and they are from three different cities, namely P, Q and R. And the populations of these cities are equal and at the same time they are very high. This table here represents the percentage of population of the blood type O from the city P, and similarly the whole table is filled. Now the question is that what is the probability that the person with the blood type O comes from the city P? Let's find out. From the table, it is clearly understandable that the person with the blood type AB is from the city R. Now let us declare an event E that two persons with the blood types O and B are from the cities P and Q, and of course no two persons are from the same city. Now let OB be an event that a person with the blood type O from the city P. Then probability of OP is 0.4, probability of OQ is 0.6, and probability of BP is 0.01 and BQ 0.1. Now the event E has only two possible outcomes. That is a person with the blood type O from the city P and another person with the blood type B with the city Q and vice versa. Hence the event E can be written as OP and BQ union OQ and BP. Now we require the probability of OP and BQ given E, because this is the only possible outcome as required by the question. Now use Bayes formula, we can write the probability of OP and BQ given E as probability of E given OP and BQ into probability of OP and BQ divided by probability of E. And this expression here is the expansion of probability of E. Now the probability of OP and BQ is equals to 0.4 into 0.1. Why multiplication? Because OP and BQ are independent events. And the probability of OP and BQ complement is equals to probability of OP, OQ and BP, because OQ and BP is the complement of OP and BQ. And that is equals to 0.6 into 0.01. Now the probability of E given OP and BQ is equals to the probability of E given OQ and BP, which is equals to 1. It is because both OP and BQ and OQ and BP are the subsets of the event E. On substituting these values, we get the probability of OP and BQ to be equals to approximately 0.87. Now there is an extension to this question. Suppose both the persons with the blood types O and B are from the same city B, and a suspect Oliver is tested and found out to be of the blood type O. Now, do these data give evidence in favor of the proposition that Oliver is one of those two people whose blood was found at the scene? Let's find out. There are two hypotheses. H, that is Oliver and another unknown person were at the scene of crime, and the complement of the hypothesis is two unknown people were at the scene of crime. And we already know that blood types O and AB were present at the scene of crime and which are from the same city P. Now to decide whether this data can be used as an evidence against or favor of the proposition, we will use the Bayes factor. Bayes factor is the probability of data given hypothesis divided by probability of data given hypothesis complement. Now if this Oliver was at the scene, the only uncertainty is of the person with the blood type AB. Hence, the probability of data given hypothesis is 0.01. And for the second case, we don't know both the people, so both of them are random. Hence, the probability is 2 into 0.4 into 0.01. And here we are multiplying with the 2 because there are two cases. That is, the first person is the person with the blood O, and the second person is the person with the blood AB, and vice versa. And here actually Oliver is also included in this 0.4, but it doesn't matter because the population is quite high. Now the Bayes factor is calculated to be 1.25. Since it is barely greater than 1, this data provides weak evidence in favor of Oliver being at the scene. Thank you. That's it from the question.